All right, in this section, we're going to be talking about the basic shapes, the basic graphs. 8 of these will be functions, and then the last 2 will be examples of non-functions, but still shapes we should be familiar with. You've been seeing some of these in some of the previous videos, but here's where they officially show up to say, hey, know about these 10 graphs, know these shapes. And then we're going to do, in the next section, is we're going to use some shifting rules and add on to how we can move those graphs around on the graph paper. Now, of course, you all have your graphing calculators. If you want to use a graphing calculator, that is acceptable. So you can download the free app, Calculate 84, or some other free graphing calculator, or use a handheld one, but that is certainly allowable. And it helps you kind of alongside what we're doing here. It doesn't substitute for understanding it, but it can help you to understand it better. At least that's what I hope is happening. All right, so follow along with me. We're on 2.6. And the first of the basic shapes we want to be familiar with is y equals x. Y equals x is called the identity function. So it could be labeled, instead of y equals, it could be f of x equals, since it does pass the function test. And we could derive some points on that graph by plugging in for x. So whatever x is, y mirror images that. It's the identity because they have the same identity. When you plug in for x, y equals that. So if you plug in 1, y equals 1. If you plug in 2, y equals 2. 3 is 3. Negative numbers, negative 1, negative 1. Negative 2, negative 2. Fractions, a half, a half. Any real number on the x, it mirrors that. So, and we learned that this is the simplest form of a line. It is linear, x to the first, y to the first. So we know that to graph to be a line. And whenever you pick some of these points, you'll see that that's so. 0, 0, 1, 1, 2, 2. It goes right through the origin, sort of like a spinner in a game. You would have just a diagonal right through the center of that XY axis. Kind of makes it a 45-degree angle there with the axis. So it's the simplest form of a line. And like I said, what we're going to do is we're going to shift these, and I know you already know this from our previous lesson that we just had. Like if we said y equals x plus 3, that would move the graph up 3 places. If we said y equals negative 2x, that makes it come down this way, a negative slope on the line. And then the 2 would make the slope a little bit steeper. So we learned some things that we can do around this shape to, I don't know, just shift it around or spice it up a little bit, but this is in its simplest form. So that's why it's called the basic functions, the most basic form of it. The domain and range of any line we know is negative infinity to positive infinity. Anything goes on the friendly line. It opens left and right without bound, and it goes up and down without bound. And of course, this is a function. Nothing repeats this way. All right, the next shape is the squaring function. When you have y equals x squared, we know that all the x squared, the second degree equations, those are called quadratics, they graph to make a parabola. This will be the most basic form of a parabola. If we plug in 0, 0 squared is 0. If I plug in 1, 1 squared is 1. Negative 1 squared is 1. So the y value repeats. That's how it bounces back up. It has that repeat for the y values, but not the x. The x does not repeat. We could plug in fractions, although you probably wouldn't, but you could plug in a half and square it. It would be a fourth. You could plug in decimals. You could plug in square roots even. You probably wouldn't, but anything goes for the domain. You can plug in independently for the x, any number for x, and you will get a real output for y. You can also see the graph opens left and right without bounds, so there's no restrictions you can see visually. Now the range on our parabolas does have a restriction. It has a lowest or highest point depending on whether it's flipped upside down. So in its basic shape, that low point is at the origin, but sometimes that changes whenever we move the parabola around a little bit. So we'll know, like if we put +2, that changes the domain, and that doesn't change the domain, but it changes the range part a little bit. So you always have to find where that lowest dip is to get the range part correct. Okay, next the third shape on your handout. I'll catch up with you here. Okay, it's the cubing function. Y equals x cubed. So again, all of these, I like for you to understand some of their t-table values, some basic points that you could find by point plotting. That's always a good way to kind of get your mind around this. This time when we plug in a negative, because it's cubed, it stays negative. So there's no repeats of anything. We can plug in -2. When we cube it, it's -8. Positive 2 cubed is 8. So there's nothing repeated at all, not the x nor the y. And then plotting some of those points, you'll see the shape looks sort of like a zigzag around the y-axis. The domain and the range are both infinities. There's no restrictions on x nor y for the cubing shape. So what we'll see in the next section is we'll have like x cubed plus 1. That'll shift the graph up one place. It won't change its domain and range though on this one. On the lines and the odd functions, it doesn't mess up our domain and range because they're all everything anyway. They're not as tricky about that. If we put a negative in front of it, we're going to learn that it's going to flip it upside down. Again, feel free to use your graphing calculator to kind of see these patterns emerging. Okay, the fourth shape is the square root function. Now we've definitely been seeing this guy around in some of the earlier sections. So you might recall that he looks like maybe what I would call an arc shape there. And some sample t-table values. You can plug in 0 in its most basic form without any adding or subtracting. 0 is the first thing you can plug in for x and get a real answer for y. Then you can plug in positive numbers, any positive number. But the next nice number is 4. When you plug in square root of 4, it's 2, and you get this shape. It is a function. The vertical line only touches it once. Its domain in its simplest basic form is 0 on over to positive infinity, and its range is the same. Low value y going up. Now, in a previous section, we learned like if you have y equals square root of x plus 3, that will change this domain and range, these shiftings or adding or subtracting. You get the same shape, it's still a square root function, but we found that it moves it back 3 places. So it looks like that. So now the domain is -3 to infinity. So just be aware the domain and range can shift around a little bit. The two main troublemakers for domain would be this radical, because you don't want to put something in that makes it imaginary. We're not allowed to have imaginaries when we graph these functions. So the square root causes domain issues. We'll watch out for that. And then the other one was the fraction. We'll see that again in a minute. You can't have a 0 denominator in a fraction. That's undefined. So those are two kind of things that you have to watch for about domain issues with these. Okay, next one, number 5. There's 10, right? So number 5. Cube root, y equals the cube root of x. You can plug in 0, get 0, 1 is 1. 8, cube root of 8 gives you y is 2. If you plug in -8, it gives you -2, so that's some sample values. And it winds up being more a horizontal shape, laid down more horizontally. It's still going up a little bit all the time and going down a little bit all the time. So it's domain and range. More obviously, domain is left and right without bound, but it's also going up and down. So the domain and range are both our infinities. Okay. And then number 6, absolute value function. Plotting a few points for that. I'd like for you to find that in your graphing calculator too. It's under ABS. That one hides a little bit. You have to look under the math button and then go to number. You got to go to math, then arrow over to number on your screen, and it says ABS. So click on that. It brings up these straight lines, and then put the X in there. So you do try that on your graphing calculator, see how that looks. I think that's the first time we've talked about that. But you should get a V shape out of that. Absolute value of X makes a V shape. Domain is negative infinity to positive infinity. You can plug in anything for x, and the output, though, is always positive. It's sort of like your parabola, only we don't have curvature to it, but it's sort of like the parabola in that the y, the dependent variable over here, keeps getting the x made positive because you plug in stuff for x, and then it makes it absolute value. So y is always up here in the positive, but no curvature because it's just x to the first. So the range, the lowest the y goes is 0, 0 to infinity. Okay, number 7. The seventh shape is y equals, it's called the greatest integer function. Sort of looks like brackets with straight lines. This is under INT. That's also in the math button. If you go to math, you'll find that INT in there as well. So find that on your graphing calculator. Do the greatest integer of x. Depending on if you're in dot mode or regular mode or which version you have, it may connect these dots, but it should look like open circles on the right side, closed on the left. So little stair steps, they're not connected between that area. So look at your screen and see if yours does that or not. You might just have to know this in your mind and have it on your notes. This is what the greatest integer function looks like. It's actually a rounding function. When you plug in a value for x, y will equal, the dependent variable equals, sorry about that, it equals the greatest integer less than or equal to what you plug in for x. So if you plug in an integer, it equals an integer. That's all these dots, like 1, 1, 2, 2, 3, 3, 4, 4, and the negatives. Those are integers. Integers are positive and negatives of the whole numbers. So that's all these dots. Well, this flat line is where it rounds down whenever you have any decimal amount, like 1.2 rounds down to just regular 1. 1.3 rounds down to 1, 1.4, and so on. So whenever you're over here, let's say this is 1, 2. When you're over here at like 1.2, it's still 1. 1.3, it's still 1. 1.4 is still 1. So it flat lines until we get to the next number, 2. At 2, we open circle to show at 2 it jumps up to be 2. And that's why it looks kind of like that. The vertical line test, because this is a function, it should not repeat, so that's filled in, but that's open. So there's never an overlap or a repeat on the greatest integer function. The domain, we can plug in anything for x, but the range only comes out, the output are just the set of integers, no fractions or decimals. Okay, and then number 8, the last of the examples that are functions, and then we'll talk about the last 2 are the non-function examples. So the last function that we're going to talk about, shape to be aware of, is 1 over x. Again, do this on your own, graph it, look at the picture, should look like this. We mentioned it in a previous section too, so we have seen this and talked about how x equals 0 is a big no-no. You cannot plug in x as 0. It would make this an undefined statement. 1 divided by 0 is just undefined. It's not imaginary, it's just not even math, not defined in mathematics. So it makes this big split in the graph where the graph repels and it gets closer and closer to that line, but it never touches at x. This x is 0. So that is certainly not in the domain. We say the domain is everything from negative infinity up to 0 with a parenthesis, so we don't touch it. And then we get up to the other side of 0 and then on to positive infinity. So just a break at 0. That's how we write that domain. The range is actually the same answer. Again, when it's in this most basic form, you can't achieve an answer of 0. To get y to equal 0 over here, you can't get that to happen because 1 is a constant and you have to have 0 divided by something. Doesn't matter what x is, but the top has to be 0 to get an answer of 0. So you cannot achieve an answer of 0. So that's not in the range. But everything else is okay. You can plug in 1, try all kinds of other number. 2 is a half, 3 is a third. You can plug in negatives, fractions, decimals, anything else, just not those zeros in its standard form. All right, so we'll come back in the next video and we'll talk about the two non-function shapes.